Hey guys, today we're doing a video on A-level physics P5, and the paper we will be doing this time around is May-June 2013 P51. Once again, I will remind you only have 1 hour 15 minutes for this paper. Therefore, time management is key. So let's move onwards with reading the question statement. Analyze the question statement, the diagram given, as well as the equation to identify any variable that would need to be standardized or measured, or both. So a student is investigating the flow of water through a horizontal tube, and this is probably it. And the rate Q at which water flows through any tube depends on the pressure difference per unit length across the tube. Interesting. So this is basically it, and the student has the use of a metal can with 2 holes. Alright, and this is the metal can, and this is tube 1, and this is tube 2. Tube 2 being in hole number 2 and tube 1 being through hole number 1. Visualize that this is not just some sort of, this is actually a complete cylinder boring through the complete 3D container, same as here. Visualization is a key skill to develop. And we have a narrow horizontal tube which goes through the hole on the side of the can, and the can is continuously supplied with water from a tap. And how is the water level kept constant? By the position of a wide vertical tube which passes through the hole in the bottom of the can. This is basically overflow. Beyond a certain limit, the water would begin overflowing. And both tubes may be moved along the hole, meaning we can shift their position to the left or to the right, up and down for this one. So what are the things you need to really keep in mind? First of all, that we are investigating the flow rate through the horizontal tube, and the vertical tube is basically just to standardize the whole setup so that we have a constant level. So let's just underline this. And the rate, that is the volume per unit time, that the volume of water that passes through the horizontal tube per unit time depends on the pressure difference per unit length across the tube. Interesting. Pressure difference per unit length across the tube. And the earth stuff isn't all that important. And then there's this is length, and this is the height, and they may both be pretty significant, and the flow rate is actually what we get from over here. So we have a suggestion that the relationship between the flow rate Q of water through the narrow horizontal tube and the vertical height. So we are actually relating two quantities, one of them being the height, the vertical height between here, which is the middle of the horizontal tube, and the top edge of the water level. And this is the flow rate volume per unit time. So meter cube per second. Vertical and the vertical height, which is this one. And what is d? We were taking t raised to power 4. Is it something that is shown? No. And this is the density of the water, and this is the acceleration of free fall is the internal diameter of the tube, and L is the length of the tube, and this is some sort of constant. And what we want to do is relate, right? So this is d, it is internal diameter, which would be in meters. And how do we get the internal diameter of something? We need to use vernier calipers. With using a vernier caliper, we can get the internal diameter of anything, and because we need to keep this a constant throughout the experiment. And the density of water, obviously it's a constant, and we do know the value, but just in case if we want to get it, density is mass per volume. So basically you can just weigh out all the water that is needed for a given amount, and take the volume for the same amount of mass, and you divide the two and you get the density. And g is obviously 9.81, and length is something you need to measure using a scale, because it seems to be pretty high from here to over there, and you need to measure this when it is dismantled, the whole, because part of it is actually within, and they do say it is movable, so there isn't any problem there. So what we want to do is to actually test the relationship between these two quantities and determine a value for this constant. So in the beginning, what do you need to do? You need to identify what the independent and the dependent variables are. And what do you do with the independent variable? That is basically the one you're actively changing in order to observe a change in the dependent one. So what is it that you can change? Well, age seems to be a bit difficult, isn't it? Because the hole is right over there. Right? And that gets us a bit confused. Right? And then there's the whole thing with the flow. We can't actually vary the age. And how do we vary flow rate? Well, that gets us to somewhere over here, that the rate depends on the pressure difference per unit length across the tube. Meaning this. How do you vary that? Well, one way to vary that is to basically vary the amount of the narrow tube that is actually within, because L is obviously the total and isn't affected. But if we move this inwards, we can actually vary the amount of pressure that is exerted on the narrow tube, and because this pressure is transmitted throughout, the pressure difference per unit length will be altered. Another way we can do this is basically we can move this upwards, so the amount of water can also be changed, and that is something that will also affect the pressure that will be exerted on the narrow tube. Confusing. I won't blame you for this. So pressure is something you talked a lot about in AS, and how do you really get the whole pressure? How do you measure the pressure of something? in this scenario it won't be that important because what we want is actually the flow rate. Right? So you don't actually need to vary, you just need to vary the pressure in order to see a subsequent change in Q, and Q is the one that you need to actually be aware of. See, so what is the independent variable? That is the one you're changing by yourself. That would be flow rate Q, and the dependent variable would then be or perhaps a better way of saying this would that the independent variable would be the height, because we can change h by changing the amount of the vertical tube that was actually part of the container. So if we move this upwards, the water level will subsequently rise and h would therefore be altered, and hence the dependent variable would be the flow rate Q. And what is something you need to really keep constant? Length, obviously, the length of the vertical tube as a whole, and obviously the diameter, which you would measure using a vernier caliper, and this is something you're changing by yourself, and this is something in which you will observe a change as a result of your tinkering. Anything else that affects, flow rate other than the height build? Well, there is rho gh. So what are the factors that can affect the density of something? Well, temperature. So we would likely need to keep the temperature constant, and height is obviously a constant, and as already measured, the length and diameter need to be kept constant, and we need to take the value of t in different orientations and average it out so that we get an accurate value. So what is the procedure to be followed? Number 1, independent, dependent, constant. Independent, height, dependent, flow rate, constant. Temperature needs to be kept a constant so that the density is unchanged. The length and the diameter of the narrow tube needs to be kept a constant, right? And the procedure, we need to know the value of the density of water, so we should weigh out a given amount of water and subsequently measure out its volume. Density is mass over volume. You get the answer. Use of a ruler to measure the length. You'll have to take the narrow tube out of the setup in order to get the complete length, and you need a vernier caliper for the diameter, and you need to take it at the beginning and at the other end multiple times and average it out, right? And procedure to be followed: you vary the height by varying the length of the vertical tube that is actually a part of the container. So if you move it, the overflow pipe upwards, the height of the water above the center of the pipe will increase, and therefore the pressure per unit length will increase, and so will the flow rate. And you measure the height. How do you? And there would be a subsequent change in the flow rate, and measurements to be taken. You would need to measure This height might be a bit difficult. Parallax error and a lot. One way of doing this is to basically measure the height above the pipe and you just add to it the radius of the pipe. Easy peasy. How do you basically measure the flow rate? Is the volume per unit. Time depends really. You may have some sort of a container down there and you basically calculate the amount in the container over a period of time, say 5 minutes, and then you divide by 5 to get the volume per unit. You may have some sort of a beaker down there and that is how you get the flow rate. We would expect the flow rate to be a constant. Right, is there something Yep, we should have a container over here to calculate the overflow water, and over here we should also have some sort of a container to collect the water. We should have a ruler vertically clamped somewhere around here. That is basically it. And analysis of the data is something you should know. As I said, this is what y is and this is what x is, and we want to change this equation into a straight line equation form because those are the ones that are easiest, but if you draw them it is easy to analyze the relationship between two factors. So if this is q and we want this to be in the form of y is equal to mx plus c, you get the idea that there isn't any c. And if h is the x, then that means 2 pi density into g d raised to power 4 over L into this n is what equals the gradient. So if you draw q on the y-axis against h on the x-axis and you get a straight line graph going through the origin, then your relationship is valid. And because we want to know the value of n, it's easy. You just basically multiply m, you rearrange it, n 2 pi density g d 4. So you basically divide both sides by ml so that you get n on one side alone, and this is the formula you need to put in. And this is gradient multiplied by the length. This is 2 pi into density into acceleration due to gravity into internal diameter trebled, no, tetraled, I don't know, whatever, just raised to the power of 4. Data analysis gone and done with. Are there any safety precautions? Somehow I doubt it, but just in case, go over this again. Water pressure might be high, so don't stand right in front of the tube. Stand far away in case the water is high. This is just a bit of a stupid precaution really. So let's go over this again. Is there anything we may have likely missed out? I don't think so. So a student is investigating flow of water through a horizontal tube. Done, nothing missed out. And the rate Q, which is volume per unit time has not been specified. At which water flows through a tube depends on the pressure difference per unit length across the tube. we have a metal can with 2 holes, narrow horizontal tube through the hole in the side of the can, continuous supply of water. So H is a constant and it needs to be a constant. So for one experiment it needs to be kept a constant. And the can is continuously supplied. Level is kept constant by the position of a wide vertical tube which passes through the hole in the bottom. Again, stuff has been standardized. And because we want relationship between H and Q, and because L and Q are actually inversely proportional, whereas L and H, so if we're varying H beyond a certain value and we increase the value of N, the value of Q would fall. So we need to have a substantial value of L so that we get a good value of Q. And diameter should be a bit larger. The larger the value of the internal diameter, the greater the flow rate. Because we want there to be the least amount of percentage uncertainty. Let's just move onwards to the marking scheme, see how well we did. Right. So we have a total of 15 marks, so we need at least 15 points and we'll see how many we got, right? So H is the independent variable because that is what you will be changing, whereas Q is a dependent variable. And you need to keep L a constant, definitely. Labeled measuring cylinder, calibrated beaker to receive water, vary position of the vertical larger tube in order to vary the height, done. Measure H and L with either a rule or a vernier caliper, yep. Measure D with a traveling microscope or a vernier caliper, yep. Measure T with a stopwatch. Oh yeah, I didn't really mention this, but I did sort of imply it, but just in case. Plot a graph of Q against H, and N would be 2 pi, yep. So how many marks have we gotten? 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe even 10. The mark over here was a bit on the iffy side of things. Reasoned method to prevent spills, example tray on the floor. Injury when adjusting the glass tubes by wearing protective gloves. Nah, we didn't really mention any of this, did we? Repeat experiment for the same H and average. Method to determine the density of water, including method to measure mass and volume, and an equation. Take many readings of D and average if straight line passing through the origin. Method to check that the tube is horizontal, not done. Detail on measuring H to the center, add radius of tube, definitely. Keep temperature constant. So I missed this out. Repeat experiment for H and average. Method to determine the density and take many D's in average through the origin. 3, 4, 5, 5. But we can only get a total maximum of 4 marks for this. So 4 over here, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we get 13 out of 15 for this, which isn't any bad at all. So what do you think are the problems faced? Well, first let's take a look at the examiner report, and afterwards something I do is I keep a diary and I write out all of the stuff I may have missed out and everything I learned, because the human mind isn't as perfect as we would want it to be. We forget stuff, and that is valuable knowledge lost. And truth is, by writing this down in a diary, we may not even manage to get it in our long-term memory. Unfortunately, some things just don't stick. At least you retain it long enough for you to be able to write it down, to apply it on your exams of all things, because at the moment those are the priorities. So, pick out a diary you haven't written in yet, and at the top of it, write down S13 question paper 51. And we'll go back to that after reading this. So, candidates were required to design a laboratory experiment to investigate how the rate Q at which water flows varies with the vertical height h of the water, and determine a value for a constant n. So if you actually write this down at the beginning as your answer statement, might be a good idea, but not the necessity. So candidates are advised to start question 1 by considering carefully the problem to be solved, and in particular the variables that need to be kept a constant for the experiment to be a fair test. One interesting thing was the density part, because whenever density is a part of the equation, even if it isn't the independent or the dependent variable, when you say density needs to be kept a constant, instead of that you must say that the temperature needs to be kept a constant in order for the density to not change. That is something we often miss out. And whenever there is measurement of something like d, such as an internal diameter, repetitive measurement at different orientations is a must, because often this thing isn't as uniform as you want it to be, and so you want to get an average of it, because that would be more true to the calculation you will use it in. And anything else? Nah. For the variables, these were the things that were a bit problematic. And repetition of results in general is a good thing to write. You get marks. One very easy mark in the additional detail section. So the initial mark were awarded for correctly identifying the independent and the dependent variable. Many candidates correctly stated that the vertical height h was the independent variable and the rate q, or the flow rate of water, was a dependent. However, some candidates suggested varying the length of the narrow tube, which did not gain credit. Would have done just that, but it would have been quite a bit difficult to incorporate, because L needs to be kept constant. We can't actually change L, because L is the total and not the part that is outside. You get my drift, right? Marks available for controlling variables, and candidates should indicate how a fair test could be made by keeping appropriate variables constant. Yep, standardization of variables that are not the independent or the dependent. As has been indicated in previous reports, the word controlled is not acceptable. Marks were available for keeping the length of the narrow tube a constant. There was also an additional detail mark for keeping the temperature of the water constant. Credit was not given for just stating keep the temperature constant. Get it? So and 5 marks available for the methods of data collection. Expected to draw a labeled diagram of the arrangement. Some did not include any method of collecting the water. Good candidates included a labeled measuring cylinder, which gained the first mark, and the second mark was available for changing the vertical height. Many candidates did not state that they would need to move the vertical tube either up or down. We did, so yay. And to investigate the relationship and to determine a value for n, most candidates realized that the vertical height and the length of the narrow tube needed to be measured and suggested using either a ruler or a caliper to do so. Candidates also realized that the diameter of the narrow tube ought to be measured. However, few realized it was the internal diameter that was needed, and thus a micrometer was not considered a valid instrument. We cannot measure internal lengths using a micrometer, but you can using a vernier caliper. A large number of candidates described a clear method to determine the rate of Q, which is good. And there are 2 marks available for data analysis, and it was expected that candidates would state the quantities that should be plotted on each axis for the first mark, which on the y and which on the x. And the second mark was awarded for explaining how the gradient could be used to determine a value for n. To gain credit, candidates needed to make n the subject of the expression, which included the gradient. Some candidates suggested plotting log graphs. Additional detail marks were available for explaining the relationship would be valid if a straight line would go through the origin and won't have any y-intercept that wasn't a 0. And this is something that needs to be explicitly stated and not just implied. And credit was not given for a sketch graph. Some candidates did not state that the line had to be straight, which was bad, lost them a mark. Some good candidates rearranged the given equation and described in detail what the gradient represented. And there was also a mark available for describing an appropriate safety precaution, which we did not, unfortunately. Candidates should be encouraged to ensure that safety precautions are relevant to the experiment and clearly reasoned. In this case, candidates were expected to describe a safety precaution relating to either method to prevent spilling or methods to prevent injuries when adjusting the tubes. 4 marks for additional detail available. Repetition of the experiment and averaging of results, and measurement of the density of water, and any way to ensure that the tube is horizontal. So this is something else that students often mess up and you can get marks for. You can use set square or something. Method to ensure a tube or a rule is horizontal or vertical completely. And this is it. Let's just see the grade threshold for this. We'll get an idea of just how well you'd have to do to get AA in this part of in this component, and this is 51, right? So you need 22. So you can miss out 8 marks, but we're doing well. So even if you lose about 5 marks in the next question, it will be alright. Obviously not preferable, but alright. Well, this is it for the video. Hopefully you found this to be as helpful as I wanted it to be. If you like, please like, subscribe and comment. It will be appreciated.